Hey guys, this is video 11.2. We're going to be talking about molarity by dilution. So this is where we already have a concentration like we calculated in the last video, but now we don't want to stay with that calculation. So this is something where we take something that is very concentrated and we want to weaken it. So we want to make it have a lower concentration by adding more solvent. Typically it's going to be water for us to that solution to weaken it so that we can actually use it. So we're going to jump right in. Be on page 7 in your notes. This is if molarity is the number one calculation that chemists do for concentration. This is probably the second most, where we need to change the concentration because sometimes, especially with acids and bases, which will be coming up here in a few weeks, right around spring break time, we may have acids and bases that are too strong to use in a reaction, so we want to weaken it. We want to dilute it. So what we'll do is we'll take a known concentration and then we will make it weaker to where we can use it. So this is how all of the acids that I get in an order, they come very, very concentrated, like 18 molar. And that stuff is so strong that it could actually eat through the floor in the classroom or other stuff as well. So we never want to use something that strong, so we will get maybe 2 liters of concentrated acid and we'll dilute it down and we can make gallons of weaker acid from that. So it lasts a really long time. So if we're given a solution and we're diluting it, we can calculate the new concentration using this formula right here. M1V1 equals M2V2. So anytime I do lab prep, this is exactly the calculation that I'm doing. This should hopefully look somewhat familiar to us. It should look like one of our gas laws that we learned about in the last unit. All right, can you think about which one maybe it is? If you thought Boyle's law, you're absolutely correct. All right, where we used P1V1 equals P2V2. So think back to help yourself kind of remember this. What type of relationship is this? Well, if one goes up and the other one has to then go down. So this is an indirect relationship. Okay, so if we're thinking about a graph, the graph would look something like this, where you have molarity, you have volume. If volume goes up, molarity is going to decrease, and vice versa as well. It's supposed to be a straight line, and I can't draw straight. There we go. So just kind of, that's a little side note, but math is going to be the same. Write down all your parts and solve for your unknowns. So let's jump in. How much 12 molar HCl is required to prepare 300 mils of a 5 molar solution? So biggest thing is we've got to recognize which one's my 1, like my starting units, and which one are my endings. So this is M1 is 12 molar. Remember, that is moles per liter. Either way means the same thing. And then required to prepare. Again, when you see that phrase to prepare, that means everything else is going to be your secondary conditions. So we're looking for V1 in this problem. We have V2, which is 300 mils. And we have our second molarity, which is 5.0 molar. Okay. Now you might be thinking, well, with my other calculation, I had to convert to liters. Guys, with this one, you don't necessarily have to. If you want to do that just to, keep it consistent every time so you don't forget, because I can tell you right now, many of you will forget that with molarity, when you calculate that, M equals N over L, you have to have liters. This one you don't, but if we want to do that, it's a really quick conversion. This would be 0.3 liters, okay? But with this one, it doesn't necessarily matter because we're looking at how many mils we could have to make our solution. It's up to you. Just make sure you know that with the other formula we learned, you have to have liters. So it might be a good habit for you if you were forgetful to just do liters every single time. All right, now let's solve. M1V1 equals M2V2. I want to get V1 by itself, so as always, I always move my variables around first, then I go back and plug in my numbers. So now we have 5 molar times 0.3 liters all over my first molar, which was 12. Molar cancels out. When you do the math, you should end up with 0.125 liters, or if you kept it in milliliters, 125 milliliters. So let's think to ourselves, does my answer make sense? Okay, my molarity went from 12 down to 5. So my volume went from 125 to start with, because I was looking for V1, and it went up to 300 mils. So yes, that does make sense based on this indirect relationship. Okay? So that's one type of way a question could be worded. This second example is another way, where it says, to how much water should this much be added in order to prepare a solution? Okay? So again, start the same way. To how much water should 150 mils of this? So we have our first molarity is 18 molar. Now guys, the other thing you want to make note of, I'm going to add this up here, your first molarity, so M1, is always going to be bigger than your final molarity. That just should make sense by dilution. Dilution means your second one's going to be weaker. Excuse me. So your first one is always going to be the larger molar value. So V1 is 150 milliliters. Okay. Added in order to prepare this. So we know our second molarity, 2.5 molar, and then V2 equals question mark. Okay, so same thing, M1V1 equals M2V2. So we need to solve for V2, divide by M2 because they're multiplying. So V2 equals M1V1 all over M2. Now we just plug it in. 18 molar times, if I want to convert this to liters, 0.15 liters, all over M2, which is 2.5 molar. Molar cancels out. Now, when we get this answer, you should end up with 1.08 liters, or it would be 1,080 milliliters if you get there. Now, notice what this question is asking, guys. It says, to how much water should? The question here, the piece you want to recognize is that this value, let me change my color, this value is the total volume you should have in the end. But notice we already have 150 mils. Okay, so how much water are we actually going to add to this solution? Well, we need to take that total volume we want, which is 1,080 milliliters. We're going to subtract out the 150 mils that we already have. Okay, so when you do that math, you should end up with 930 milliliters of water is what you're going to need to actually add to the original amount that you had in order to get this 2.5 molar solution. Okay, so when you're doing dilutions and you're trying to figure out, well, what's the final volume, you have to remember to take into account what you already have in the beginning. Okay, because if you just added 1,080 mils, well, added it to the 150 you already have, now you're going to be more dilute than what you wanted. So your molarity won't be 2.5 molar, it would be something like maybe 2.2 or less or whatever based on that. Okay, so if you're asked to figure out how much water should be added, you have to subtract out your original amount. So you guys go ahead and try this problem on your own, and I'll go through and do it here in just a second. All right, so again, to what volume should? So this is like that problem that we just did. So we have M1 equals 15 molar. We have V1, which equals 0.035 liters. M2, we're looking for a 6 molar solution. So V2 equals question mark. Okay. M1V1 equals M2V2. I want to get V2 by itself. Divide by my second molarity. So V2 equals M1V1 all over M2. Plug and chug. 15 molar times 0.035 liters divided by 6 molar. Those are gone. When I do this math, sorry, I'm doing the calculation right now, I get 0.0875 liters, or if I was going to convert that to milliliters, guys, it'd be 87.5 milliliters. But again, to how much should that 35, how much water should we add to it? So we need a total of 87.5 milliliters. We need to subtract out the 35 mils that we already had. So we're going to add a total of 52.5 milliliters to dilute it down to get that final volume, final molarity of 6 molar. So if we wanted to go from 15 molar concentration at 35 mils, we would need to add 52.5 more milliliters to our solution in order to take it down to 6. All right? So those are the two types of problems. Go ahead and work on practice number 3. If you have questions, ask.